So we need u and du, we need dv and v. We need 4 pieces. And the formula that you need to know, the little recipe, is sitting right here. uv minus integral of v du. That's what you have to know. By doing the notes today, practicing it tomorrow, or today, doing the notes tomorrow, practicing it tomorrow, you'll have that memorized. Now here's an example. X and cosine of x, as far as one being the function and the other one being the derivative, that relationship is not here. So the first thing we try when we get an integral is, can we do this with u substitution? We can't. So now we're going to go to integration by parts. We're going to let u equal the polynomial almost every time. The only time we won't let the polynomial equal to u is if we have natural log, like in example 3, we have x natural log of x. We'll get to that. dv in this case is equal to cosine of x dx. So I grab the x and we grab the cosine of x dx. We have it all. We've grabbed everything. du is equal to, well, let me do it like this. I'll only do it one time like this. The derivative of u with respect to x is 1, right? The derivative of x is 1. And then we can multiply over the dx. So du is equal to dx in this case. I had one person ask me earlier in the day, how are you just writing that dx to the other side? I hadn't shown it that way. Everybody okay with those steps right there? Everybody good? Okay. V is the integral of cosine. We're backing up to the function. That is sine of x. Now we have all 4 pieces, the u, the du, the v, and the dv. The recipe is u times v, x sine of x, minus the integral of v times du, which is sine of x, and then in this case it's just 1 times dx. And the question is, do we end up with something that we can integrate? Sure, I know how to integrate sine. So this is x sine of x, and the integral of sine of x is negative cosine, so that's plus cosine of x plus c. We're done with the problem. And I'll only do this one time today as well. If we take the derivative of this, do we get back to this? That's the question. So first times derivative of the second plus the second times the derivative of the first minus sine of x. Those cancel out. We end up with x cosine of x, which is exactly what we started with. So it works, in other words. We're only going to do that once. I don't ask you to verify all these. Sometimes we have to do this twice, repeated use of integration by parts. So let's let u equal x squared. We almost always let u equal the polynomial. du equals 2x dx. dv equals e to the x dx. So v equals e to the x. Let's get to class, please.
We're doing classes.
Okay, all right, cool. I'm not in the mood, apparently. I didn't know I wasn't in the mood till right now. X squared e to the x minus integral of v du. So 2x e to the x dx. Well, I mean, we made progress, but we still don't have something that we can just take the antiderivative of. Because we've gotten better. It went from x squared to 2x. And if we do this one more time, this derivative will be a constant. And then we're kind of home free there. So u equals 2x, du equals 2 dx, dv is e to the x dx, and then v is e to the x. So we're doing this one more time. That's all we need. We have to do this twice. I'll never ask you to do more than 2 times with these. So we bring this with it, x squared e to the x, minus, all right, now we're doing the whole process just on this. So u times v is 2x e to the x minus integral of 2e to the x. And now that we have that as a constant, now we can actually take the antiderivative. So the final answer is x squared e to the x minus 2x e to the x, and then it ends up being plus 2e to the x plus c. So we had to do that twice. Now, if this was multiple choice or even in the back of the book, it'll factor out an e to the x. You have x squared minus 2x plus 2 plus c, and you can see how it goes x squared, 2x, and 2. It keeps taking the derivative, right? Wow.
What? What? You say, okay, join the DEI club.
All right, any questions so far? All right, let's do this one. Solve the differential equation subject to the initial condition y equals 1 when y equals negative 1 when x equals 1. We don't do all the confirming. Let's split the differentials. And we're going to integrate. So this is what it means to solve a differential equation. Go back to the original function. We got y is equal to, well, now we need to do integration by parts on this side. This one's a little different. I'm not going to let u equal x on this one. I'm going to let u equal the natural log of x. Because I know what the derivative of natural log of x is, I don't know what the antiderivative is. I actually do. It's so complicated you don't want dv to be natural log of x. Trust me. So the derivative is 1 over x, and we'll make the polynomial the dv. So v is 1/2 x squared. The pattern is u times v, 1/2 x squared natural log of x minus the integral of v du. Well, 1 over x times x squared is x, 1/2 x. Now we have something we could take the antiderivative of. Minus 1/4 x squared plus c. Let's finish it out. Negative 1 is equal to 1/2 times 1 squared, natural log of 1, minus 1/4 times 1 squared plus c. So we show that we're using the values. And I could have done this in my head. You can too. I give you the same speech every time. Make sure you're showing this, right? So we got negative 1 is equal to, it's just going to be negative 1/4 plus c. So c is equal to negative 4/4 plus 1/4, negative 3/4. So then we finally get the answer. Minus 3/4. There we go. Now, of course, I want you to be able to do all of this, but I think the key to this one right here was making u equal to the natural log of x on that one. So make u equal to the polynomial, except when you have natural log in the problem. Then you don't want to do it that way. It'd be much harder. Much harder. Any questions so far? This one is a little easier than the last section, I think, because it's more algorithmic. It's more do this step and then do this step. And if you follow these steps, you'll be fine. Last section was a little more, you had choices to make. And sometimes those choices are pretty tough to find out what u is. Example 4. We don't have a polynomial on this one, so neither one of these, if we took the derivative of these forever, they would never go to 0. You'd never get a constant. If you take the derivative enough times on x squared, you'll end up with, you'll go 2x, 2, and then 0. You'll get to 0. These they won't. So this one takes a little bit of work. These are fairly long, but you'll have to do integration by parts on this twice. We got to get back to this statement right here, and you'll see what I mean. Let's go. Let's u equals e to the x. Du equals e to the x dx. Let's go dv equals cosine of x dx. And v is equal to sine of x. And it wouldn't matter which one you picked for u here. It wouldn't matter. It'll work out exactly the same. Now the pattern is u times v. e to the x sine of x minus integral of v du, e to the x sine of x dx. And it really doesn't look like we made much progress. Matter of fact, all we accomplished was changing cosine to sine. That's okay, because if we do this one more time, we're going to change sine back to cosine, and that's what we want. So let's write it like this. Well, let's do this. U is equal to e to the x. Du is e to the x dx. dv is sine of x dx. And v is negative cosine. That'd be the antiderivative. I'm going to write this like this. I'm going to take this and write integral of e to the x cosine of x dx is equal to, we'll bring this with it, e to the x sine of x. We'll bring the minus with, but it's like we have this brand new problem, this brand new process right here. And that's u times v, negative e to the x cosine of x, minus the integral of v du, which is negative e to the x cosine of x, which makes that a positive, negative and a negative. So e to the x cosine of x dx. That's equal to e to the x sine of x plus e to the x cosine of x minus integral e to the x cosine of x dx. And believe it or not, this is what we wanted. We needed this to be a minus, and we needed this to be the same as this. And really what we have, if I said get y by itself, what would you do? Get y by itself, what would you do? Add y over, right? And you get 2y, z, and then divide by 2. That's exactly what we have here. This thing and this thing are the same thing. So we'll add this over. And divide by 2. So our answer, the integral of e to the x cosine of x, which is what we wanted to find, is equal to 1/2 e to the x sine of x plus 1/2 e to the x cosine of x plus c. There we go. So you got to do integration by parts twice to get back to where you started. If this sign right here is a plus, you did something wrong. Because we can't cancel them out. Because you would minus it over and they'd cancel out. We can't cancel them out, so that has to be a minus. If that's a plus, you did something wrong. Questions on that? That's a nice little check to see if you're on the right track. Unfortunately, the nice little check happens at the very end. All right. So there's the kind of the different things that we're going to see. We have one other thing that you're going to love. And seriously, this is awesome. There's a pattern to all this and the pattern kind of pops up right here where this was the integral of e to the x is e to the x, and the derivatives goes x squared, then 2x, and then 2. But because of that minus, it's not quite exactly just the derivative. It has this extra negative that's being distributed through, and we got to make up for that. So here's the shortcut. It's called tabular. It's the shortcut to integration by parts. You're going to love this. We write x squared as the side we're going to take the derivative of, and the integral part, we're going to start with e to the x. So you write what you see. And then this side, we're going to do the derivative until we get to 0. And we can do this because one of them is a polynomial. We can't do tabular with this one. It won't work. We don't have a function that will go to 0. Then we take the integral of all this. And if we did a bunch of these without doing tabular, I think we could figure out the tabular method. I think we could figure out the pattern. But we don't want to spend all that time. I'm just going to let you know what to do. Now, because of that minus that we distribute through, you got to have some extra signs. It always starts with plus, and then it alternates. Minus, and then plus. And you do the little diagonals. I call them diagonals. And then you put those signs in. So the table is set up Now all we have to do is write out the answer. And this is all multiplication. It's like taking x squared times positive 1 times e to the x, which is just x squared e to the x. Then 2x times a negative 1 times e to the x is minus 2x e to the x. And then 2 times positive 1 times e to the x is plus 2 e to the x plus c. And then we don't have to go through all of that integration by parts. I mean, we are, but it's a shortcut version of it. I suppose you could probably figure out a way to do this tabular, but I don't know. It'd be a little confusing. Where do you stop? Any questions on that? Do you want to try it then? I'll just do it because we'll talk about how you integrate all this stuff. So how about dx? I got another one for you to try. X to the third, 3x squared, 6x, 6, and 0. So this is going to be a lengthy answer. I think you'd have to do integration by parts 3 or 4 times on this one. So we're saving a bunch of work by doing this. The other one, we're going to take sine of x, and we're going to integrate. Now remember, it's integral, it's not derivative. So this is negative cosine of x, negative sine of x, cosine of x, sine of x. Because in the pattern, because in the formula we got that minus, and we would distribute a minus through, you got to add some extra signs in there. If it was all plus, we wouldn't have to do this. You start with plus, and then you alternate signs. And now we just have to write the answer. So negative x to the third, cosine of x, and then minus and minus is a plus. So plus 3x squared sine of x, plus 6x cosine of x, and then minus 6 sine of x, plus c. Lengthy answer, but it's the time required to do it is shortened by the tabular method. It doesn't take that long. It'd take forever if we had to do it the long way. Questions on tabular? Just got to follow that pattern. And today's a lot about patterns. Just know the pattern, you got it. Well, what is the antiderivative of natural log of x? We're going to let u equal the natural log of x. And we're going to let dv equal, well, the only thing left after I grab natural log of x is dx. Or in other words, 1 dx. du is equal to 1 over x dx. And if I integrate, v is equal to x. The pattern is u times v, so x natural log of x minus, and 1 over x times x is 1, so we have the integral of 1 dx. v times du. So the integral of natural log is x natural log of x minus x. That's why you don't want to do, you don't want to have natural log be your dv, because you'll have to remember that that's the antiderivative. Not fun. That would not be a fun problem. So make your u the polynomial, except when you have natural log, then make that the u. And your life will be much easier. Are we good? All right, ready to practice it? Try number 2. Find the indefinite integral. On your homework, you're not allowed to use tabular until it says you can. So you can't use tabular until number 21 in your homework. After this section, after we are completed with this section, you can do tabular anytime you want. But I want you to practice not doing it in the section. So no tabular here. So we got what? U equals x. Du equals 1 dx. dv is e to the x dx. And v is, well, e to the x. X e to the x minus integral of e to the x dx. So I get x e to the x minus e to the x plus c. And in the back of the book, you might see this. I'll write it. I'm not going to do this every time, but hopefully you're going to recognize that you can factor the e to the x out. If that's on a multiple choice, hopefully you can recognize that that would be the answer. Try number 8. In this case, we're going to let u equal natural log of t. dv is t squared dt. Because we know what the derivative of natural log is. It's 1 over t. It's much easier than making a dv and find the integral, even though you could probably get that to work. I've never actually tried it. 1/3 t to the third. So we have 1/3 t to the third, natural log of t, minus integral of 1/3 t squared dt. So you have 1 over t times t to the third, t squared. And we pretty much have it. Minus 1/9 t to the third plus c. What do you think? Questions on that? It's not too bad. This section is not too bad. It's a lot of writing, but I think the process is fairly straightforward. Let's try one of these. Let's practice number 18 here. This is the one where you got to get all the way back to that expression. So you have to do this twice. I don't think that's right. Can you see the monitor shaking? Can you see it shaking? Can you see it? When it's really windy out, it shakes the whole building. So it shakes that up there. You can see it. You can see it bounce. I can always tell when it's windy out because I'll look up here. It's bouncing a little bit like that. All right, the u is equal to e to the negative x. Negative e to negative x again. Now when we do this one more time, we'll get back to cosine. So v is negative cosine of x. So our original, e to the negative x cosine of x, is e to the negative x sine of x plus, all right. Oh, did I mess up? Go ahead.
In that first equation,
Yeah.
the integral with the e to the x to the negative x.
What now?
So that you have your
Oh.
second equation of
Oh, no. I have a plus here, right?
okay.
Didn't I make up for it here?
Yeah.
Because it's minus, minus, and that's a plus? Okay. All right. Negative e to the negative x cosine of x. Minus minus is a plus, so minus e to the negative x cosine of x dx. I guess I didn't read parentheses if that's a plus sitting there. So that we got 2 e to the negative x cosine x dx equals all this junk. And we'll divide by 2. So this is equal to 1/2 e to the negative x sine of x minus 1/2 e to the negative x cosine of x. This is indefinite, so we need plus c. So you get back to what you started with. And that better be a minus on the end or else you did something wrong. We have to add it over. We can't minus it and cancel it out. Do you guys want to move over to the middle one from now on? Yeah. Let's just put you there for the rest of, I'll make a new seating chart and I'll make sure no one's sitting in that table because the sun's blasting you. How about integration by parts? Should we practice that a little bit? Go. A little dry today, but all we need is a little practice and we can get this. We like tabular though, it goes quick. Derivative. 2x minus 5 to 0. Integral. Oh, we like e to the x. Need some extra signs in here because of that minus in the little formula. Plus, minus, plus. It always starts with a plus, and then you alternate. We got x squared minus 5x e to the x minus 2x minus 5 e to the x, and then plus 2 e to the x. So let's see, what would we get at plus c? If we factor out e to the x, we'd get x squared minus 5x minus 2x is negative 7x, and then 5 plus 2 would be plus 7. So that could be a possible answer that you might see. So you factor out e to the x and then collect those like terms. All right, let's finish it up with this one right here. Evaluate the integral analytically. Support your answer using your calculator, in other words. So this is not a definite integral, or it's a definite integral, so we won't have the plus c. Let's use tabular, though. Let's go x to the third, 3x squared, 6x, 6, and 0. We have cosine of 2x. Oh, what's the antiderivative of cosine of 2x, though? What would we have to have there? 1/2. Well, we have to have a 1/2, right? Because with the chain rule, we're going to multiply by 2. So this is going to be 1/2 sine of 2x. Remember, chain rule, we're going to multiply by 2, so we're going to need a 1/2 to cancel that out. Then a negative 1/4 cosine of 2x, negative 1/8 sine of 2x, and then 1/16 cosine of 2x. Diagonals. So 1/2 x to the third sine of 2x. Oh, plus, minus, plus, minus. So plus 3/4 x squared cosine of 2x minus 6/8 or 3/4 minus 3/4 x sine of 2x, and then 3/8 negative minus 3/8 cosine of 2x. And we're going to evaluate from 0 to pi over 2. The good news is a lot of these are going to be 0. Like, for example, the sine of pi is 0. So that's 0. Cosine of pi is, negative 1. So minus 3/4 pi squared over, not 16, 4. Pi squared over 4, right? Because you're going to square the half. Sine of pi is 0. So that's really minus 0. Cosine of pi is negative, so I get plus 3/8. Now, lots of stuff is going to be 0 here. It's going to be, every time we plug in a 0, 0, 0, and 0, but not this one. Cosine of 0 is 1, so minus 3/8. So the final answer is 6/8, which is, 3/4? 3/4 minus 3/4 pi squared over 4. Clear, clear. 3/4 minus 3/4 times, somebody wants in, I'm almost done. Okay, that's the decimal value. Math 9. 0 to pi divided by 2. X to the third. Cosine of 2x. X. Hey, we got it. I figured it out. I knew where my mistake was. I found it. I was, this morning, I was doing the cosine of pi here, and I was getting a positive 3/8, and then we couldn't figure out where I was going wrong. It's cosine of 0, it's 1. I was making that negative 1 this morning. And for the life of me, I could not figure out what was going on. Anyway, yeah, that's integration by parts.